Hello everyone. So today I'll be explaining about tensegrity concept, where normally usually what happens is when it comes to traditional truss, I'll give an example right now. Here what happened is one of my project where I used to work. So there we had around 20,000 square feet building, and we had to work on this kind of a truss where it costed us around maybe it close to around 1.5 crores or something like that for just for the truss works. So imagine we are spending a lot of money on the truss work. So the project was around 3 crores, and half of the project was costed just for the truss work. So imagine, is there any way that it can reduce the trust design cost? The trust cost. So I have come across through a lot of articles. I've read about a lot of things, and here I came up with one of the concept where I could use tensegrity concept to linking with the tensegrity. Traditional trust, so I can reduce the cost. So first of all, let me show you guys how the tensegrity works. So this is a compression member and a tension member. So these are the concepts how the tensegrity works. There are a lot of YouTube videos you guys can watch where you guys will understand how the tensegrity works. So coming through this, myself Vignesh. Here I'm going to explain you guys how I'm going to transform the tensegrity using the tensegrity concept to the traditional truss. So let's start. So traditional trusses, how it is normally like a pin connection where we need to use a lot of hot roll sections, cold roll sections, and it will increase the cost because normally how it works is when the contractor takes as per the ton. So how much of the ton we are going to use, ton of steel we are going to use, it costs so much for us. So welding cost, maybe welding, grinding, cutting cost, and laborers. It'll cost us more. And tensegrity is a compression member, and it is a continuous tension member. So improving the efficiency. Here I am where I'm going to integrate tensegrity to the truss where I can reduce. This is what I think. I can reduce material usage, enhance adaptability, and create lighter and more resilient structures. So let me bridge a gap between conventional truss and the traditional trusses where we'll understand this concept and it would make you even feel that yeah, this is a good concept once you understand this. Yeah. So what are the objectives right now? Here I'm going to apply tensegrity principle where I'm going to reduce the material efficiency. Reduce the structural weight and improve material efficiency, enhance adaptability by varying loads and environmental condition. And we'll be comparing the conventional truss performance. So this is a latest stage. So right now I'll be only giving you ideology how it works. So let's identify real challenges. What is there with implementation of this? So when I came through these lot of articles, I've understood that there are some of the limitations that come when you use tensegrity concept. So complex pre-stressing where precise tensioning is required, and there may be a failure of fatigue, there may be a cracks due to these materials, and there may be elongation of materials when tensioning. But we can resist all these things by using a lot of new initiation, like new project in a modular way. I'll come up with that. There are challenges that can be reduced by investing some of the amount to the for the improvement or maybe research and development. That is how it works. And here, due to corrosion, there may be, and even due to the temperature changes, there will be a slight problem with the durability of the material. And advanced materials is required in some sense because right now to the bottom we can use maybe a hot roll section, and to the above we'll be using cable members to take the sheet load. And normally, how it works in the convention is we use hot roll section itself. Here we are going to reduce this cost. And challenges is it needs maybe advanced worker or maybe a skilled labor, something like that. So materials, normally high tensile steel cables are used. I'll be showing you the images how it will work. So to the top, I'll be using aluminum or lightweight metals to the sheet roofing area. And we can use fiber reinforced polymers and glass fiber reinforced polymers for gaining the high strength to weight ratio and corrosive corrosion resistance. So this is the ideology. So right now, this is a normal. The left side you see it is a traditional truss. So that is how it is. And here, this is a new method that I would like to implement, where we are going to use the tensegrity concept to these areas wherever I'll be showing you the sectional views. So here, what happens is the conventional way we are going to use this concrete column. So this is how it will be, and we'll be giving a proper development length in this case because we need a proper anchorage for the support. And to the beneath, we'll be providing the cables. So cables, maybe a steel, maybe a steel wired cables and chains, all those things. So we can do according to the. I mean, once we try it out, we can figure it out how we can do it, but it would be better that we get an elongated thing so that the material won't crack or something like that. So, so here the cable support will be provided, and to the bottom we'll be giving the steel section where we'll be welding or maybe we'll giving a bolted sections or something like that, and we connect the bottom section, steel section, and to the top we'll be providing the beam section. We'll be doing a built-up section, something like that. Only to the middle there will be a steel section. Rest everything will work with on cables, so that you guys can understand how much the reduction of steel will be. So maybe if the normal conventional truss, if it is costing us around 100%, we can reduce it to around 40%. So this is the minimum that we can reduce. And if you are going to work on this in an advanced way, we can reduce in a lot well managed. So this is what it is like. So here the beam section, I'll be using it here once again. I mean, this is a Y section, no? Section 6, Y. So here, whatever the here it is, you can see this out here. So this is the beam section, and to the bottom, whatever you see a steel section that can be visible. And here, instead of using the steel members, we are going to use cable members, and we are going to reduce the cost. So this is one thing, and here we need to use this concrete column. So this is what you guys can see. So this is how it works. So as what I have seen right now, to the top, if you're going to use a light material, and we can reduce the material components, and due to the changing loads, so due to the dynamic loads, so we need to make it so it is unpredictable, and we need to reduce the or stability. I mean, the point is the material. The people say that the tensegrity thing, the concept where it is not stable, it moves around, and when there is a wind load or seismic load, because it is a dynamic load, there is a chance of wobbling. So we need to reduce that by implementing a lot of methods. We can do that. We can reduce the movements. So we can use advanced materials and shape memory alloys and self-adjusting polymers respond to environmental changes, so that can be used implemented in this sense. So to conclude, I would say that the tensegrity concept is going to increase the material efficiency and reduce weight and enhance adaptability in truss design. And if you are going to give a proper support from the modern sustainability, I mean modern support, I mean modern technology, all those things, we are going to give support to us to increase the efficiency. It is a great start, I would say, and this is a new concept that I would come up with. I mean, there is a lot of tensegrity concepts going on now, but people have not adapted this to the trust, and this will be a big game changer. This is what I think. And if you guys would like to work on this, and if you guys want to research on this, or maybe have more discussion about this, uh, uh, do contact me through this mail ID. So khvignesh123 at gmail.com. I'll be available in contact. Thank you.